The next one, amperage versus voltage. When you guys are doing your tests, it takes voltage or pressure to push flow or amperage through a circuit. Okay? So when we do a voltage check, that'll tell us about pressure. Amperage tells us about flow, and they're two different measurements. It's like having water pressure to wash your car, and so you check the pressure before you turn the hose on. Man, I got 100 pounds pressure to wash my car. And as soon as you push the nozzle, it only has a half a gallon per minute. So it just drips out the end. You just lost all your pressure, you have no flow. Okay? And there are two different tests. If we want to check amperage, we can do that with the way that I encourage you to do it is with an amp clamp. Okay, a clip over the wire, which will gauge the magnetic field and tell you the amperage flow. That'll tell us if we're getting correct flow. That's how we check starters. That's how we can check lights, a lot of different circuits. Now there's a reason that I like to do this. When you use the picoscope or a lab scope, amperage versus voltage, you will see something like this. If we have, I'm going to use 12 volts. If we're running 12 volts to an injector, as soon as the computer turns that circuit on, the load uses the voltage. Basic theory. And the voltage drops down near zero. It's not going to be all the way to zero, but it's going to be near zero. Okay? The second that happens, the amperage drops, or the voltage drops to zero, amperage starts to flow. So our amperage is going to be running here at zero. And the second this happens, the amperage is going to start flowing. Now it's not instantaneous. You don't take your car and go from 0 to 60 instantly. You accelerate. Okay? And so this is called a ramp, or an amp ramp. And it's the way the amperage starts to flow through there. Okay. Now we're going to reach a peak, and as long as this voltage is at zero, your amperage is going to stay up here, flowing current. As soon as you shut this off, our voltage is going to climb back, but we build a magnetic field. We created a magnet to open that injector to spray fuel. When that magnetic field collapses, it's going to induce a voltage. So we're going to get a voltage spike that comes up. We're going to dissipate that voltage spike, and it's going to come back down to our system voltage. This one, your amperage is going to be flowing like this, and the second that is shut off, the amperage drops down and goes back to zero. Okay, now you all did that with a lab scope, didn't you? Mm-hmm. Okay, so this should make sense. Now, I wanted you to see this in this relation. We did this as part of class. And part of the reason we did that is for the next step. We're going to move to the next place. That's amperage diagnostics. Amperage diagnostics work extremely well to help us find a problem in different circuits. According to theory, amperage is the same everywhere in the circuit, in a series circuit. Is that correct? We measured them, we checked them, we did them as part of class. That is correct. We proved it. So, with amperage diagnostics, just for example, if I don't start the car, if I just turn the key on, that means as soon as I turn the key on, everything that is powered in that car has to flow out of the battery, correct? So I can go to the battery cable, and I turn the key on, and I go up to 15 amps, and 2 seconds later it drops down to 8 amps.
Fuel pump.
That's the fuel pump, okay? I can tell if the fuel pump comes on and how much amperage it takes just by checking on the battery cable. Amperage diagnostics is great. You don't have to be one of the guys laying under the car, pounding the dirt off, trying to find the right wire, you know, dirt falling in your face, trying to get in there and check for voltage. With amperage diagnostics, since it's the same everywhere in the circuit and it starts with the battery, you can tell if the fuel pump works without even climbing under the truck or the car. Is that logical? Mm-hmm. Okay. The same thing with a light. Or anything. I looked at one 2 days ago for a customer downtown. He said, my truck doesn't start right, it's a diesel, and I don't know if I have a problem with glow plugs or not. I said, well, let's check the difference from side to side. You have one heavy cable that comes to a solenoid, and the solenoid's energized. There's two heavier wires that come out, one to one head, one to the other. So we took 2 amp clamps, put on both wires, turned the key on. This one went to 180 amps, this one went to 95. Do we have a problem? Mm-hmm. We know that one of them is way low on amperage from the other one. We have to have some burned out glow plugs. Okay, you have a problem on this head. I can't tell you how many are burned out, but we know that you have a problem, and it's on this side. And so when you do those glow plugs, they're kind of a pain, aren't they? You just did some. What did it take you, about 4 hours to do them?
My dad started, he did one head, I did the other head, and that took about 2 hours.
So 4 hours total?
Probably took him a shorter time.
Now he's got a little more experience, but that's pretty close. Well, wouldn't it help to know which one to take apart?
Both.
Okay, so the guess. Okay, so amperage diagnostic works. If we have a problem with our headlights being dim, we can turn the lights on without the engine running and everything leaves the battery, and I can tell you exactly how much amperage those lights draw just from the battery cable. I can tell fan how much the fan draws. There's a lot of different things because the amperage is the same everywhere in the circuit. Excellent way to test different things to get an idea where to go, because the basic theory is true. Amperage is the same anywhere in the circuit. Okay, now I have listed one